Hi everyone, welcome to today's presentation, which is about the derivative of trigonometric functions. In the previous presentation, we have learned what are the derivatives of trigonometric functions, and we have also proved one of them. Today we will see some of its examples. So here we have a question that if f of x is equals to secant x over 1 plus tan x, then find the derivative of this function. As you can see here, this function is made up of trigonometric identities. So for finding the derivative of this function, we need the derivative of trigonometric function as well as the rules of derivative. Now if you have memorized the rules and the derivative of trigonometric functions, you can solve this question easily. First of all, we need the quotient rule. Then we can further solve it. So what quotient rule says, the denominator times the derivative of numerator minus numerator as it is times the derivative of denominator whole divided by whole square of denominator. So this is the quotient rule. According to this, 1 plus tan x as it is times the derivative of secant x minus secant x as it is times the derivative of 1 plus tan x whole divided by 1 plus tan x whole square. Now for further solving it, we need the derivative of this trigonometric function secant x, and we also need the rule which is the sum rule. We have to use sum rule right over here. So it will become 1 plus tan x, the derivative of secant x which is equals to secant x tan x minus secant x as it is, and here we applied the sum rule which is derivative of 1 plus the derivative of tan x whole divided by 1 plus tan x whole square. Now for simplifying it, we will multiply these two, and for solving it we need another rule which is the derivative of constant. Here we need the derivative of constant rule, and here we need the derivative of a trigonometric function which is tan x. So it will become, by multiplying these two, it will become secant x tan x plus secant x tan square x minus secant x as it is, the derivative of constant function which is equals to 0 plus the derivative of tan x which is equals to secant square x whole divided by 1 plus tan x whole square. So here you can see we have used three different rules of derivatives and the derivative of trigonometric functions. Now we will simplify it. So it will become secant x tan x plus secant x tan square x, and when we multiply these two, it will become secant cube x whole divided by 1 plus tan x whole square. Here we can take the secant x as common, so it will become secant x into tan x plus tan square x minus secant square x whole divided by 1 plus tan x whole square. We take secant x as common. For further simplifying it, we need an identity of trigonometric function which is tan square x plus 1 is equals to secant square x. Here in the function we are given this secant square x. Here we will use tan square x plus 1, so it will become secant x into tan x plus tan square x as it is, minus, in the place of secant square x we will write tan square x plus 1, and plus and this minus will give us the minus. So now we can cancel out these two terms, and it will become secant x into tan x minus 1 whole divided by 1 plus tan x whole square. So this is the derivative of that function. This is how we can differentiate a function which involves the trigonometric identities. Now we have another example which is find the 27th derivative of cos x. Here the function is cos x. We have to find the 27th derivative. This is a trigonometric function. How can we do this? We have to find the 27 derivatives? No, we don't need to find 27 derivatives, what we need to do is find some few derivatives. First few derivatives of f of x is equals to cos x, and the some few derivatives of, or some first derivatives of cos x are, first derivative of cos x is equals to minus sin x. Again, when we differentiate it, the derivative of sin x is equals to cos x minus sin as it is. Then again, differentiating it, we know that the derivative of cos x is equals to minus sin x, and this minus sin as it is, and it will give us the sin x. Fourth derivative of sin x is equals to cos x, and the fifth derivative of the function is minus sin x. Here you can see the given function was cos x, and the fourth derivative of that function also gives us the cos x. So from here we can see that the successive derivatives occur in a cycle of length 4. In this question, the successive derivatives occur in a cycle of length 4. So what it says that in particular the nth derivative of cos x, the nth derivative of cos x will give us 4 cos x only if n is the multiple of 4. From here we have seen that if n is the multiple of 4, then the derivative of the cos x will again give us cos x. So for finding the 27th derivative, what we have to do, we know that 6 is the multiple of 4, so we know that 24th derivative of x, which is cos x, will give us the cos x. Now differentiate it 3 more times to get the 27th derivative, and it will become the 25th derivative is equals to minus sin x, the 26th is equals to minus cos x, and 27th is equals to sin x. So this is how we can find the 27th derivative of cos x, which will give us the sin x. This is how we use the laws of derivative and the derivative of trigonometric functions to find the derivative of trigonometric functions. Here we have another example that find the limit x approaches to 0 sin 7x over 4x. It seems very difficult that how can we solve it. When we apply the limit directly, it will become undefined. So what we can do, this is the given function. We will multiply and divide this function by 7, and it will become 7 times sin 7x divided by 7 times 4x. 7 multiplied by 4x. So we can rewrite it like 7 divided by 4 into sin 7x over 7x. Here it is same like sin h over h or sin theta over theta. So we need to find this limit, and it will become 7 over 4 limit x approaches to 0 sin 7x over 7x. Here if theta is equals to 7x, then theta approaches to 0 as x approaches to 0. So it will become 7 divided by 4 limit x approaches to 0 sin theta over theta, if we put theta in the place of 7x. And we know that this limit is equals to 1 by using the squeeze theorem. This limit is equals to 1. So as a whole, the limit x approaches to 0 sin 7x over 4x is equals to 7 divided by 4. This is how we can find the limit by making this identity.